This naturalrefrigerants.com article is being read by an automated voice. Proposed EN 378 standard seen as having significant advances for natural refrigerants. By Michael Gary, published August 26, 2025. The European Committee for Standardization, CEN, has released an updated draft version of the safety standard EN 378 for voting and comments by national standardization committees and other stakeholders. The draft version, officially prEN 378:2025, was issued on July 3rd and will be open for voting and comments until September 25th. A final vote will occur in 2026. National standards bodies and CEN member states, which will vote on the proposed standard, provide a means for individuals to access the draft standard and submit comments. Interested stakeholders can visit the website of their national standards body, such as in Spain, the Netherlands, Ireland, and the UK. The new version contains significant advances for natural refrigerants, particularly for hydrocarbons, according to a Uramen webinar on August 19th, given by Daniel Colborne, co-owner of UK consulting firm Refrigerant, which specializes in low GWP refrigerants, including flammables. Historically, the standards requirements have been reasonable for CO2 and ammonia, but very obstructive for hydrocarbons. It is essential that prEN 378:2025 receive positive votes, and that stakeholders submit comments for clarification and technical corrections to counter the considerable opposition from anti-natural refrigerant interest groups, said Colborne, adding, negative votes will be used as justification to tone down elements that support naturals. Most problems in the prEN draft relate to flow logic clarity and interlinkages between requirements, he said. It would be catastrophic for any part of the updated standard to fail, said Colborne. The proposed standard, which would update the current edition, EN 378:2016, lists requirements for the design, testing, installation, and operation of refrigeration, air conditioning, and heat pump systems, ranging from small to large capacities. It consists of 4 parts: prEN 378-1, General Definitions, Charge Limits; prEN 378-2, System Design, Construction, and Testing; prEN 378-3, Installations; prEN 378-5, Refrigerant Data. Part 4, on Operation, Maintenance, Repair, and Recovery, is being replaced by ISO 5149-4. The main changes to the standard regarding refrigerant charges are in Part 1, noted Colborne. Natural Refrigerant Trade Group Uramen said it welcomes the standard's more flexible and risk-based design approach, which could better accommodate the unique properties of natural refrigerants such as R717, R744, and hydrocarbons. However, the group is urging further improvements, particularly to charge limit restrictions and overly prescriptive safety caps that still pose barriers to wider application of natural refrigerants. Uramen is encouraging stakeholders to support the revised standard by voicing expressions of approval to national standardization committees. Changes in Part 1. According to Colborne, the major changes in Part 1 of the proposed EN 378 standard involved a determination of room size for refrigerant amounts, determination of refrigerant amounts, intrinsic and extrinsic design methods, capped quantity limits, refrigerant quantity safety limits, charge limits, the releasable charge concept, integrated mitigation measures surrounding concentration testing. EN 378 does not set a single hydrocarbon charge limit for equipment like commercial cabinets, but provides a calculation method and maximum values that depend on the refrigerant type, the room size, and the safety classification of the equipment and location. The general standard EN 378 establishes different classes of location and access categories, which determine the maximum refrigerant charge that can be used considering the flammability and toxicity class of the refrigerant. For instance, a system with a high quantity of flammable refrigerant may need to be located in a machinery room with a certain type of access, or in a room with a ventilated enclosure or outdoors, noted component manufacturer Carrel. Colborne explained the specific changes and quantity limit requirements for flammable refrigerants in a presentation last year in Dublin for the Institute of Refrigeration Ireland. The charge limits for flammable refrigerants can be found in a number of international standards for refrigeration, air conditioning, and heat pumps, including ISO 5149, IEC 60335-2-40 and IEC 60335-2-89. In Europe, in addition to EN 378, there are EN versions of the IEC standards, while other regions have their own versions of the global standards. This results in varying charge levels for hydrocarbons. For instance, noted the International Institute of Refrigeration, IIR, the upper charge limit for domestic refrigeration is 150 grams, while the upper charge limit for commercial refrigeration ranges from 500 grams to 1.5 kilograms depending on the standard.